So one of the things that's important to think about when you're looking at function tables is first you want to look at the function. So a function is basically just an equation, and it's an equation that uses variables. In this case, the variables we have are y and m. 2 plus y equals m. Now, don't let those letters scare you, because remember, they're just variables. They're just placeholders for numbers that you can plug into this equation, or this function. So let's plug in the number, let's say 3. So we're going to plug in the number 3 for y. And if we know that 2 plus whatever y is equals m, then let's go ahead and take our equation over here and just write it out. So 2 plus, now we know for this one we have a y. So, we have a 3. So let's plug in that 3 instead of, or for y. And that equals, well, 2 plus 3 equals 5. So that's pretty easy. With a little bit more complicated problem, you can go ahead and still do the same thing. So set up your function, r5 minus 2 equals b. So we have two variables, r and b, and we want to figure out what b is. So let's plug in a 4 into the r, and we know if we do that, we get, or we have to set up our problem. So r turns into 4. So according to order of operations, 4 times 5 is 20, we minus 2, and then we get 4 times is 20, yeah, minus 2, and then the next thing is we need to do our subtraction, and then we know that 18, or b equals 18. You can just keep on going with that. Let's just plug in another number. It doesn't matter what number. Let's just go with the 6. So we set that up. 6 replaces r, and we do our order of operations, and we end up with b equaling 28. And you know, you can just keep on going with this. You can plug any number you want in there. Let's try a 10. And now we know that, you know, if we do our order of operations, b equals 48. And you can keep on going with this just basically forever if you wanted to. I kind of like to think of function tables as like little machines. So say we have this like function machine, and you know, we plug something in and we get something out. And I do like applesauce. Next thing we're going to do is let's take a look at what would happen if we had to think about graphing. And we know that the x and the y axes, basically we're talking about when you have both those things, you can kind of create points, or coordinate points. Now, no understanding coordinate points, you know there is an x-axis and a y-axis. And let's do an equation that uses x and y as variables to kind of help us with this. So let's just do a simple function table with 2x plus 1 equals y. Okay, so in this case we're going to find out what the x and the y coordinates are, or numbers are, using a function table. So let's plug in our x. We know we're going to go, let's just do 1, 2, 3, 4, something easy like that. We already have our equation, so now let's find out what y equals in this case. So if we have 2x plus 1 equals y, and we plug a 1 into the x coordinate, we know that we're going to get a 3. Okay, so that's not so bad. Well, if you use a 2, you'll get a 5, and so on, just like what we just were doing. And that's just kind of what that would look like for that equation and that function, 2x plus 1 equals y. Now let's graph it. Now, if you remember how to do coordinate points, you know that the x is, the x coordinate is the coordinate that you would look at first. And we know that it's going to be measured by counting over on the x-axis. So we know if we're going to count over 1, because that's our x-axis, let's just do that. So count over 1. Then we got to do our y-axis. We know we have to go up or down depending on if it's negative or positive. In this case, we know our y for this set. If x equals 1, then y equals 3. So let's count up. 1, 2, 3. And that is going to be our point for that first section. So let's keep on rocking. We know we're done with that. We know the 1, 3 has been recorded. Let's go ahead and do the 2, 5. So we know that we count over 2, count up 5. That's our next point using this function. Now remember, in a function table, you can plug any number you want into x. We're just going 1, 2, 3, 4 to make it easy for now. So a 2 and a 5, so we know that's our next point. Let's try a 3 and a 7. Well, we know if we count over 3 and go up 7, our point's going to be there. Pretty cool. And a 4 and a 9 would go up even further at the same rate. And what's cool about a function table is if you're following, you know, the kind of the rules that I laid out for you here, and then you have your function table with an x and a y point, you can like figure out what y would be with any x. And so we know that that line keeps going on forever in both directions. So you can plug anything into x, and you would get a number in the y category. They would give you a point right on that line that I just drew. It's not very straight, but I'm doing my best. Anyway, so that's kind of just a summary of, you know, how function tables work and how you can use them to graph coordinate points.